10.3, we are going to talk about music. So in music, you are, listening to a bunch of sound waves that are actually in a pretty organized pattern. And music varies between people, right? So you could have a favorite music that someone else might absolutely hate. And someone else might have a favorite music that you might absolutely hate. And you might think that, a lot of people might think that music is just a bunch of noises that are combined together. But I'm going to show you a picture in a little bit about what it looks like to have music and what it looks like to have noise. And you're going to see that noise is actually just a bunch of random patterns and random pitches, okay? So this is what noise is. But when we look at music, we're going to notice that music is actually a collection of sounds that have a pattern to them. So that is the main difference that you are going to need to know between noise, random patterns and pitches, and music, which is a collection of sounds that have a pattern. So here you can see in this image noise and how, the waves that the noise makes is just jumbled patterns. But when you have music, it's a lot more organized and there is a pattern to it. So they're all kind of going in the same movement versus noise. You can't really predict what's going to happen next because they just look very different from each other. So natural frequency is something that we are going to talk about when we talk about music and sound. Basically, what natural frequency is it's a particular set of frequencies that every material and every object has that causes them to vibrate, okay? So it's a set of frequencies that a material or object has that allows them to vibrate. So this can be musical instruments that use them so that they can control the pitch that they are expelling. So if you have a guitar, they all have natural frequencies. And, each guitar string is going to have a different pitch because each guitar string produces a different type of sound. Resonance is another important vocab word when it comes to talking about music. What is resonance? Specifically, it talks about how sound is amplified when a music instrument is being played. Now remember we talked about natural frequency in the previous slide. A natural frequency is when you have a specific set of frequencies that every material and every object has that causes them to vibrate. So when you have a material and object that is vibrating at their natural frequency by taking in energy from another object that is also vibrating at the same natural frequency, you have resonance. So this example is playing a saxophone. A lot of musical instruments have something called a reed, which they put in the mouthpiece of the instrument. And basically the reed allows vibrations from your lips to be carried through inside the instrument, and it causes the air inside of the instrument to absorb energy and vibrate at its natural frequency. Therefore, it makes the music inside of the instrument louder. There's also something called sound quality. So when your friend is playing a note, say they're playing a flute, because that's what they play, and they're playing a note on a flute, and then the note of the same pitch that they just played on the flute is also played on a piano. If you close your eyes and you're listening to the flute and the piano, you could tell the difference between the two instruments, right? You would be able to tell that one is being played on a flute and one is being played on the piano. The sound would not sound the same, and it's going to be easily distinguishable. And that's because each of these instruments have a specific sound quality. So what is sound quality? Sound quality basically describes the differences you have between sounds of the same pitch and loudness. So this is why we have the ability to differentiate a piano from a flute or a flute from a piano, because we're able to look at the sound quality and see the difference between the two sounds because of the pitch and loudness that differs between them. There's also something called overtones. So musical instruments vibrate at many different frequencies when you play them. They're not just going to vibrate in one specific frequency, but because there's different notes, they have different frequencies that they will have and exhibit. And this also happens even when you play just one specific note as well. So it can happen between different notes, and it can happen between just one note. So when you have a low frequency, the lowest frequency that is being played, that is called a fundamental frequency. And so on a guitar, its vibration of the entire string going back and forth can be an example of a fundamental frequency. And this will determine the pitch of the note that you hear. So again, fundamental frequency is the lowest frequency you can have on instrument, and that describes the overtone. So what is an overtone? A vibration whose frequency is a multiple of the fundamental frequency. So this is when you have the determination of a sound quality of one note that's being played on an instrument that you hear. So when you play a flute and a piano, you are producing the same fundamental frequency on both instruments. But the reason you can differentiate between them is because the loudness of each overtone differs between those instruments. So I'm going to say it again. When you have a fundamental frequency, right, you are pretty much, it can be varied or it can be similar. But the reason that we're able to differentiate between two instruments that have the same fundamental frequency is because of the loudness that differentiates between each instrument because of the overtone that they exhibit. So what is a musical instrument? Basically, a musical instrument is any device that is used to produce a musical sound. Okay, so this is your these are examples right here: your violins, your bassoons, your flutes, drums, and you can also have clarinets, you can have saxophones, you can have your wind instruments, and then you can also have your combination of like guitars, keyboards, banjos. All of those are types of musical instruments. And again, those are just any musical instrument is any instrument that is able to produce a musical sound. So there is one group of instruments called strings. This is usually what you hear. You can have an orchestra with violins, cellos, basses, and these are like your violins, guitars, and harps. So these are examples of strings. Make sure you know these examples. And the way that you get a string instrument to produce sound is you can either pluck the string, you can strike the string, you can draw a bow. Usually that's what you use for a violin. And then they also have something called a resonator. So a resonator is pretty much a hollow chamber that is filled with air that helps to amplify the sound when the air inside of that instrument is vibrating. Okay? So it's a hollow chamber filled with air that amplifies a sound that is inside of the instrument, causing it to vibrate. Electrical guitars, they have something called pickups, which convert the sound from the strings that they have into electrical signals, which then are amplified before being converted into sound. So again, they have pickups which convert the sound from the string into electrical signals, which then get amplified before they're converted into sound. Wind and brass instruments, these are your flutes, your saxophones, and what happens with them is that you have a lot of vibrations of air inside the wind instrument and or brass instrument, whatever, and they can determine the frequency that those instruments produce. And so these vibrations are really what are producing the sound that we hear. Examples of wind instruments can be pipe organs. These are pretty big. If you've ever been to like a huge cathedral or big churches, you might have seen pipe organs. They're pretty fancy and absolutely beautiful. Brass instruments are your saxophones, your trumpets. And then, a lot of times you might have noticed that wind instruments are usually very long, and that's because the length of the vibrating tube and the air that is inside of it can actually help determine the pitch of the sound produced. And so, the longer it is, the shorter it is, does determine how much music and sound that instrument makes. Then we have our percussion. So percussion, they have membranes that are stretched over a resonator, which is a hollow chamber that is just filled with air that helps to amplify sound when air inside vibrates. We talked about this a couple slides ago. And that vibrates, causing air inside of the resonator to vibrate. So when you have this membrane that's stretched over a resonator like a drum is, you are able to amplify the sound coming from the air that is inside of that drum because of the vibration. And so when you hit this membrane, the resonator amplifies the sound because of the air vibration inside. Whenever you talk about music, obviously you want to talk about beats. And this is when you have, for example, if you hear two flutes that are playing the same note, but they are not tuned right, you could probably hear a pulsing vibration in loudness. So you might be able to differentiate how the difference between them, and that they're probably not in tune because you hear something called a pulsing vibration in the sound that they're making. And this pulsing vibration is called the beats. And sometimes it's good to hear and sometimes it's not. And I don't have a figure on this slide, but in your textbook there is a figure in chapter 10 that really shows you what the beats look like. And when you have a beat, the vibration, it's pretty much a vibration in the loudness, which is what we hear as sound. And sometimes it's not comfortable, like we said. So when you increase the loudness, the compressions overlap the other compressions, and you have a loud sound. When you have a low amount of sound or a low amount of loudness, you have compressions and rarefactions that overlap each other. So I'm going to say it again. When you have compressions that overlap compressions, you have loudness. Okay, your loudness is increasing. But when you have compressions and rarefactions that overlap each other, loudness decreases. And again, I would take a look at the picture in your textbook that kind of shows what this is. So that's what a beat is. So beat is a pulsing vibration in the loudness that you hear from music or an instrument. And the loudness depends on if the compressions and rarefactions are overlapping, which means you have a lower amount of loudness, or if you have compressions overlapping each other, which means that your loudness is increasing. So, to which is sound quality most related? Sound quality is most related to overtones, okay? And remember, when we talk about overtones, we are saying that this is an example is when you have the flute and the piano producing the same fundamental frequency, but the loudness of each overtone will differentiate between the two instruments. What part of a musical instrument amplifies sound waves? A resonator. Remember, the resonator is that hollow tube that has air inside of it that vibrates, that allows sound to be amplified. So a drum can have this, a wind instrument can have this as well. So let's do a quick 10.3 quiz review so that you can take your quiz. So we talked about in this section, music is a combination of sounds that follows a specific pattern. Noise has random patterns, okay? So noise has random patterns, but music has a specific pattern. Quality of a sound will tell you the difference between the same pitch and the loudness of the sound. Natural frequency, which all objects and material have, is a frequency at which that material tends to vibrate when it's disturbed. So each object and material will have a specific frequency that they vibrate at. And then a vibration that has multiple fundamental frequencies is called overtone. And overtone allows you to differentiate two instruments that are playing the same note, but you're able to say one is a piano, one's a flute. When you have air vibrating inside of a medium, it will cause resonance inside of it because of the energy that it's absorbing. So that's resonance. Remember, this can happen in drums, or it can happen in wind instruments. And that's it for our quiz review. Very short, so make sure you study and review all your stuff. If you have any questions, you can refer back to your textbook or rewatch this video. And then we will move on to section 10.4.